For those of you that don't know, the Dalton Nuclear Institute is celebrating its 20th anniversary this year. And to celebrate, we've launched the Dalton Expert Insight Series, bringing together researchers and experts across the Dalton community together to share their experience and knowledge. Today, we're joined by a load of experts to talk about robotics and AI. This will be a different format to the previous ones, which were more lecture styles, because this will be more of a panel discussion, so asking lots of questions. And we're planning to go beyond the reactor from the fuels and reprocessing and talk about the wider nuclear operations of robotics. We'll touch upon many areas in today's session, such as decommissioning, remote operations, inspection and maintenance, but we'll also be looking to the future of what robotics may hold for our next generation of reactors, both fission and fusion. We want this session to be as interactive as possible and led by you, the audience. So please feel free to think of questions and ask as we go out throughout the day. I know I'm interested in learning more about the AI and autonomy and how we can incorporate this onto our nuclear sites. We want this session to almost demystify robotics and AI, as it's not a tool, as it's not a solution to all our problems, but it can be a very powerful tool. So on that note, it's my great pleasure to introduce you guys to our panel of experts, formed both academia and industry with a wide range of experience and knowledge. I'll keep my introduction short, because listing all of their accolades will take up most of the session. But I also want to allow them the chance to talk a little bit about their own work and their own research. So firstly, to start on the far end, we have Professor Michael Fisher, who is a professor of Computer Science and a Royal Academy of Engineering Chair of Emerging Technologies at the University of Manchester. He's the academic lead for CRADLE, the Centre for Robotic Autonomy in Demanding and Long-Lasting Environments, which is the prosperity partnership between the University of Manchester and Amentum. He co-chairs the IEEE Technical Committee on Verification and Autonomous Systems. He's on the BSI and IEEE Standards Committee on Robotics and Autonomous Systems, and he's currently on secondment to the UK government advising on AI and robotics in the Department of Science, Innovation and Technology. Secondly, we have Dr. Mel Willis, who is the academic research lead for future technologies at Sellafield Limited, where she leads the robotic integrated research team and supports the manufacturing integrated research team, which is responsible for the deployment, development, and technical delivery of low TRL robotics and manufacturing projects from universities and supply chain companies. Her role involves understanding the decommissioning challenges both at Sellafield and across the wider NDA estate. Next, we have Dr. Bruno Adorno. He is a reader in robotics at the Department of Electrical and Electronic Engineering here at the University of Manchester, and he is a Sellafield Royal Academy of Engineering Senior Research Fellow. He's the Associate Editor of IEEE Robotics and Automation Letters, and is the Deputy Academic Lead for RACO, the Robotics and AI Collaboration, which is a £21 million collaboration between the University of Manchester, the UK Atomic Energy Authority, the Nuclear Decommissioning Authority, and Sellafield. And lastly, we have Michael Oates, a senior robotics engineer working for the engineering development team at Amentum. He specializes in robotics and remote operations and has led several projects working in both fusion with the jet reactor and STEP, as well as decommissioning in both the UK and in Japan. He also works as the industry engagement lead as part of CRADLE, aiming to utilize academic advancements in robotics in real-world client-driven use cases. So thank you all for joining me and giving up your time to be part of this panel. How this panel is going to run is I have a few questions to start off the discussions, and then we'll open it up to the floor and online to ask questions throughout the session. So please feel free to start thinking of them now as we go to our speakers. So firstly, I wanted to ask if you guys can briefly, in a few words, in a couple of minutes, just introduce your areas of research, your background and current projects and challenges that you're trying to tackle and face. So if we start with Michael on the end.
Okay, thank you for that short introduction.
That was a short one compared to
Yes, so thank you for the invite. Great to be here. So I'm a computer scientist. I don't really build robots, but I build that bit of stuff in the middle that actually controls all the robots. So the software is becoming increasingly important. And the particular research area I work on is trying to make sure that the software, whether it's AI or other software, is actually going to do what you want. Trustworthiness, reliability, can you trust this stuff? Especially when we get to autonomy. Can you trust this stuff to do the right things once you let it loose? So that's my research areas.
Hi, thanks for having me today. So again, I also don't build robots. I want to use them. So my role is to understand what research is going on in academia and how that can then be applicable to the nuclear decommissioning that we're doing at Sellafield, and also the other way around. What gaps have we got at Sellafield where we need new research to happen? And I'll come to the likes of Bruno and Michael to help me solve those problems.
Yeah, thank you for the invitation. I'm a classic roboticist, so I work mostly on the foundations of robotics. I've been working on theoretical robot dynamics, kinematics, and control, but also applied to many different domains. So before working with the nuclear domain application, I was working across many types of domains, including surgical robotics, with one of our colleagues who is there in the back. And the goal currently in nuclear robotics is to tackle challenges where robots need to operate in confined environments. They need to tackle very complicated terrain. So my last research has been focused mostly on legged robots with manipulator arms, because they can traverse those very complicated terrains. They can be agile, but also dexterous. That's me.
Cool. So hi, I'm Michael. My kind of, I guess, area of speciality, and the reason that I really like doing the job that I do, is we get loads of really unique, bespoke R&D jobs for robotics across different sectors, but a lot has primarily been in nuclear, fission and fusion. So we'll get a task brief come in to access a really confined area or a hard to access, really demanding environment with lots of different environmental challenges. And each time we're researching, developing and producing different robotics or autonomous or remote operation systems that can go in and do this job remotely. So hopefully I can give a perspective of what it's like to be on the front line actually trying to make these robots to put into something like a nuclear reactor.
Cool, thank you all for that. So to start off with, this first question is probably more directed towards yourself, Michael and Mel. It's how is robotics and AI currently used across the nuclear industry? How are we currently using them, if at all?
Where are we not using it? One of our key areas really is kind of that inspection and maintenance things. We've got lots of facilities on the Sellafield site and across the wider NDA estate. So the NDA is the Nuclear Decommissioning Authority. They manage all of the nuclear sites across the UK that are currently undergoing decommissioning. So these range from Gerais, which is on the very north coast of Scotland, about 20 minutes from John O'Groats, all the way down to the likes of Winthrith, which is on the south coast. So they manage all of those. And really, we've got lots of facilities that we need to keep in this kind of care and maintenance state. So they're not being used, but we're also not ready to demolish them. Maybe no one has set foot in them for 30 years, and we don't really know what state they are in on the inside. So a lot of times we would much rather send a robot into those kind of environments rather than sending a human in, because we don't know what the infrastructure is going to be like. The other half of it is the facilities that are currently still in operation. These are a little bit more tricky because operations have to continue while we're doing the inspection and maintenance. We have got congested pipelines, we've got tanks and vessels that need inspecting, and so we're using robotics to do all of that. And we use robotics across the domain. So we've got aerial vehicles, which we use to kind of monitor the outside of buildings, legged robots, ground robots, and underwater vehicles as well. We've got several ponds at the Sellafield site used for nuclear storage. And that was kind of our first ever use of robotics, was an aquatic robot, underwater ROV, and we've been using those on the Sellafield site for nearly 30 years now.
Cool. I think that sums it up, and that's where it kind of passes over to our side, is to make the robots to do all those jobs. It's an interesting one, so it's different. It very much depends on the environment you're going into. If it's a storage pond, which is a more understood environment, that's where it's a bit easier to deploy robotics. I've been doing it for a long time. Yeah. And then that goes up to the more challenging environments, which is maybe what we get the new projects and the really demanding projects now. So we did one a few years ago for Fukushima to design a robot to go inside the reactor core and take a piece of debris out. And what's interesting about that is, so it shows that we've started off decades ago using robots in the easier to access areas, and now the industry is picking up and trying to put them into the areas that we previously didn't think was as possible, and now we're tackling. What's challenging about that is, like you've referred to, we don't know what's in there. A lot of these reactors are really, really old, or the majority that we're working on are really, really old. The drawings that we're working from are dated. It wasn't all properly backed up in the same way that we will do now. So we don't know what we're going to encounter. And they weren't designed back in the 1950s with the thought of, oh, we need to send a robot in to maintain something. So one example is this robot that we put into the reactor core. Nobody ever thought we'd have to do that. It was through some massive, long, convoluted 20-meter long path. The maximum size of the robot was about a 140 millimeter diameter circumference. So you have to make something that can traverse that route, fold up into a really small space, expand when it gets there, and there's all these different challenges. So every problem is unique. But what's good now is the industry is, I think, picking up pace and accepting that robotics should be the best practice of way of doing things. So it's great for our company and me because we get all these interesting challenges thrown towards us.
Can I, well, abuse your system by changing the question slightly?
Yes.
Which is, why is robotics used more in the nuclear industry? And I think not only nuclear industry, lots of industries have realized that if you put robots in a place instead of people, that's great for safety, because suddenly, you're not in danger. But as soon as you replace a person by a remote controlled robot, typically efficiency and accuracy goes down, and suddenly this is quite hard to deal with and doesn't do as well as perhaps the human would on their own. And that's often a barrier in lots of different, I don't know, it's particularly a barrier in nuclear, but lots of different sectors have the barrier. And it's making a step from that to autonomy, where suddenly not only do you not have the humans, so the safety is better, but actually they're more efficient, more accurate, and more reliable if you just essentially let them go without a human trying to remote control these things. So that sort of barrier is often in a lot of sectors where we are at the moment, that we can remote control these robots, but the step to letting them go is a barrier either because, well, we do have the technology, either because there's a regulator involved or the organization doesn't feel this is, they're risk averse, if you like, and don't want to do this, or maybe the people involved don't want this thing to happen. So there's sort of barrier there. But once we get to autonomous robotics, let these things go and make sure they're trustworthy and reliable, then you can do lots of interesting things.
Very interesting. So follow-up question to that, because you mentioned a lot of barriers. What are the current barriers to entry for robots on nuclear sites, and how can we solve some of them barriers, break the barriers down to get more autonomous systems on?
There's a few, and none are on their own that insurmountable. I'd say the one that we come across the most is, I would say, that trust. How can we trust that that robot, even if it's being remotely operated, is going to do what it should be doing? Around that, then, we've got cybersecurity concerns. When it's gathering that data, how do we ensure it's staying on our site and not being released anywhere else? There are funding constraints that we can be prohibited by. There are cultural aspects, which you've kind of covered. And one that we came across when I first started in this role was people were worried that actually robotics was going to take their jobs, with replacing a human with a robot. What we've actually found is since introducing them, people have been much more accepting of them, because actually what we've been able to do is upskill our workforce. So instead of them being an operator, they're now a robotic operator. So they operate the robot, they're in charge of it, they've still got that control, but they're just out of that really hazardous environment. And the feedback that we've got from our operators is actually they much prefer being a robotic operator than they do being an in-person operator, if that makes sense. So one of the recent deployments we've had is through Spot the Dogs. That's the Boston Dynamics quadruped, which I'm sure you've all seen. We had a facility on the site that no one had been in, and essentially we needed someone to go in and just bag up all the rubbish that was in there. We could have sent humans in there, but they would have had to have worked in air-fed suits, so they have big PVC suits. You get very hot, very sweaty. It'd be like working in a bin bag, essentially. The airflow is rubbish, and it's just not a nice environment to work in. So instead, we upskilled those operators and we taught them how to use Spot the dog. So Spot goes in, he lives in the facility now, he bags up all the rubbish and just brings it to the door. And so the operator now just has to open the door and take the bag out. And they love it, it's much better for them. So we are getting there with some of those hurdles, but really the kind of trust side is a big one for us.
Can I pick up on Michael's answer? So I think that there is also a very big technological gap between teleoperation and full autonomy. And I think that the current approaches might not be very suitable to achieve full autonomy, and I explain why. Because you cannot just abstract the robot away and design full autonomy, assuming that everything will work accordingly, because this is part of what people do in terms of autonomy, right? Formal methods for autonomy. But I think that there is a disconnect, because one of the reasons why robots are too slow and they cannot be operated in a fully autonomous fashion is that the action perception loop is still very slow. So you can see robots in manufacturing plants. They work very fast because everything is very structured, and you don't need to feed the perception, the high-level perception, back into the loop. You have lots of feedback, but not the high-level feedback. So I think that a stepping stone for achieving full autonomy that will bring more trust, I think, is having a kind of mixed thing in which you have shared autonomy and shared control, where you still have humans in the loop because they can bring perception into the equation. For humans, it's very easy to identify and to reason about things at a very high level, even if the task is completely unstructured. But for robots, that's not the reality. So those who've been working with task planning at a high level and merging with low-level control know how difficult it is to make it in a very performing way. So I think that having this shared control scheme where you have humans in the loop but working at a very low cognitive load will require theories and techniques that don't exist. So it's not a matter of just merging existing technologies and thinking that if you put more money, you're going to achieve it. There's loads of theoretical work across this whole pipeline in order to make it work. And even if you achieve full autonomy, at some point, you need some degree of intervention. And we do it all the time. So we have, in organizations, for example, we have this hierarchical system where when things go downhill, there's always someone picking up the pieces, right? So someone intervening. And it's the same for robotics. So it's virtually impossible to remove humans in the equation, at least with what we have now. I don't know, in about 100 years, 200 years, I don't know, perhaps, but not now. Now I think that we need to have this high range of functionalities where we go from direct teleoperation up to full autonomy, but full autonomy, I believe, will be confined to very narrow situations currently, at least in the next 10, 15, 20 days.
Thank you guys for that. So we've talked a lot then about some of the limitations of the autonomy side of things, but what are the limitations of our current systems, and are they unique to the nuclear application, or are they more widespread?
We like to think they're unique, but they're not. When we go out and speak to other industries, everybody's got the same kind of challenges, whether we're speaking to the railways or National Grid or British Telecom. We've all got challenges that are the same. We just like to think we're special, but
So I'd agree. They're all very similar challenges. There are other places that have it highly regulated. There are other places where you have unpleasant radiation. There are other places, or even worse, we have communications delays, like space, for example. Lots of places are not very nice. And sort of going back to Bruno's point, I slightly disagree that we can do autonomy, but the other point is, at some point I agree, something will break when you're in these unpleasant environments, whether it's a physical thing or some software will fail. And having a human intervene to fix it is fine, but actually why not have the system fix itself if it can? We're trying to do that in places where you can't directly intervene, like space, for example, because there's a delay. Why not do that in the nuclear as well? You can get it to not exactly physically repair itself, but reconfigure the software to cope with, one wheel doesn't work very well, or a gripper doesn't work very well, but you can still do things. That diversion
No.
I think there's kind of, there is one thing that we as, maybe more later down the line, is more of a specific challenge, but again, not specific, but it's definitely heightened in nuclear in that it comes back to we're working in environments that are extremely confined and we don't understand. There aren't many environments where we see something to the same degree. For instance, there are lots of infrastructure challenges around robotics that we're tackling with Cradle, but there's a more open, easy access environment. And what's particularly challenging, I think, really why we've had to put so much manpower into robotics for nuclear, is that thing where every single, whether it's a repair operation or inspection or designing something new for fusion, every single robot that we design seems to be unique. And that's more from a end design perspective rather than a theoretical level with academic research, but it does slow it down in that if every single pipe that we need to do a repair operation on needs a completely different robot, we've got to develop a different robot to do each one, which is a real problem for the old fission reactors because they're not well understood. They were designed so long ago. It's something now that we're going into fusion, so work we're doing with ITER, etc. Since that's at the design stage, that's a message we're really trying to get across to them, that if we want robotics to be efficient in that environment, we need to think about them as we're designing rather than in retrospect after we've done it, so that we can design even just something as simple as having the space for a robot to get in and have a standardized set of robots that could do a number of different operations rather than a new robot for every single job.
Sorry. Thank you, guys. So I suppose this is more of a sillier question, but we've seen in recent years the uptake of ChatGPT, these generative AIs, large language models. Why can't we just put one of them onto a robot and send it into a nuclear site? Because what people see this as a solution,
you can do what do you want to do then? You can't guarantee anything about it. That's the problem. So I know it's slightly flippant, but the use of AI is really important, and choosing the right sort of AI for the right part of the system is really important. And lots of obvious places where AI is used, like object recognition, things like that, but using things that are very hard to security, you mentioned, they have bad security problems, they're very hard to trust because you don't know what it's going to say, and whether it's going to be truthful or not. Using that sort of AI as somehow a controller or a decision maker is difficult, and you can't really guarantee anything about that. But there's lots of AI you can use in different parts, maybe not just that. I mean, maybe you can use ChatGPT to help the robot explain to the operator what's been going on in a better way, but not to make big decisions about everything, I would say.
Yeah, and we're talking about high-level decisions, right? Because imagine, for example, an offshore facility with loads of pipework that you want to disassemble. And the robot needs to traverse that particular thing. And I'm thinking about a situation where, part of the structure collapsed. The robot needs to go inside and repair it. But before doing that, it needs to traverse this small corridor, which is confined with loads of pipework. So you have a ChatGPT, so what? Because you need to have the perception pipeline to identify where the pipes are. You need to have a decision process. You need to have motor control. And when I say motor control, think about like a human, it's not motor in the sense of engines, right? Or a joint motor. I'm talking about, coordinating the whole motion in order to traverse that particular thing. So you won't do it with ChatGPT. And people might say, well, we could use another type of machine learning technique based on reinforcement learning, etc. But those kind of things depend on training the system, right? And as humans, we don't need to be trained on how to traverse, that bunch of pipes and debris. We just do it, right? Even though we encounter that situation for the first time. And why is that? Because we have several layers of reasoning which are not based only on induction, but also deduction, right? So I think that the problem is much more complex. And the way we're tackling the overall robotics architecture sometimes is a little bit easier for us humans to reason about, but it's less efficient in terms of how robots should operate. And I think that we currently have two paradigms. This paradigm where we segment the robotic system into layers like motor control, then we have trajectory planning and motion control. Then we have high-level reasoning. Then we have perception spanning the whole thing. Or other people from another school of thought, they think about end-to-end learning, right? And in my opinion, both approaches are just wrong. I mean, they can be complementary at some point, but I think that at some point we need to start merging some layers in a way that makes more sense, right? In a way that you connect the perception with the action loop, in a way that you can introspect into the system, prove properties not only at a discrete level, but at a continuous level, so you can certify those systems. This is one. And secondly, as I said, one of the main bottlenecks is the action perception loop. Therefore, if you make it efficient and proper with the guarantees you need, you unlock new capabilities, and then we can start thinking about full autonomy in a broad sense.
So, all of you guys here today are in some way, shape, or form part of different research organizations and collaborations. We have Cradle and RACO, predominantly here at the University of Manchester. How impactful do you guys believe these partnerships and collaborations are on actually achieving systems on site and actually furthering the robotics and getting robots?
I think they're going to be key for advancing robotics in the industry and other industries as well. Like I said, we're not alone in our challenges. So why are we building bespoke robots every time we've got a new problem? We should have a toolkit of robots that are standardized, that other industries are already using. Let's bring those in. Yeah, they might need tweaking. Occasionally, we might need to develop a new robot. But I think by working together, sharing our challenges, sharing our knowledge, Sellafield as an entity, we're not researchers. There are people on our site that can build a robot, but that's not what our bread and butter is. That's not what we're here to do. That's what these guys are here to do. So we need to tap into their knowledge. Where we can help is whether we think the robots that they're building will work in our environment. And that's the knowledge that we have and that what we can share. So I think going forward, I think these collaborations, I think are really going to pave the way for how we develop robotics for the future, ensuring that while there are occasions where we do need bespoke robotic solutions, that is not our go-to every single time, because that's not achievable. That's not going to see us using robots as business as usual, which is ultimately where we want to go to.
I agree completely. Maybe another comment as well, particularly about Cradle, is, as we've sort of discussed already, it's not nuclear isn't the only game in town, and the issues are similar. And the regulators across all these different aspects, if you can get them together and say there are solutions from one area that can help in another, and have a convening power, if you like, of getting all these people together, you can push forward regulation and reduce some of the barriers that we mentioned already, but both in nuclear and in other sectors as well. So these sort of organisations are really useful for that as well as the research and the deployment.
Yeah.
I think from our perspective as the industry or world, and being part of Cradle, I think the reason that we see so much value in it is, at least from my perspective, every project that I've been involved in where we say we're putting robotics into nuclear, what we mean by that is remote operations. Everything we've actually developed so far, and this is what's been talked about already, it's always human-in-the-loop control, because that's what we know how to do at this stage. And it's not to diminish that. That is a major stepping point. That is step one in getting robots into an environment such as nuclear. But then step two is what Michael and Bruno are talking about, which is getting that automation in. And that's more front-level research at a university side rather than on an industry side. So for us, as the corporate world, it's really important to work with that, so we can start to, we feed into step two and step two feeds into us, and we can work together to move towards that.
Yeah, to me, I agree with everything, and there's another motivation for me, I think. So what you said about having different types of robots for different types of application, but sometimes they could be standardized, or you could use a more general purpose robot, right? So for me, whenever I see different challenges being tackled by different robots, and I can foresee that using a particular technique with a particular robot structure could solve those problems altogether, for me, it's a very good motivation, because I can see that the theory for generalizing those robots in a way that makes sense for you guys in the industry is challenging from a theoretical and practical perspective. So it results in academic research, which is great because that way we're pushing the boundary of the state of the art. But then if everything goes according to plan, now instead of using 3, 4, 5, 6, 7 robots, you have just one and costs diminish, right? And then you unlock other capabilities as well. There are two things currently. So you mentioned AI. Nobody here has been talking about AI mostly, right? But because AI is overhyped, but extremely overhyped now. But another platform which is very, very much overhyped, it's humanoids, right? So you talk about humanoids and people just cringe. And I like humanoids, but from an academic perspective. And why? Because they are not useful yet. Because if they were in a way that every industry could use it, it wouldn't be academic research anymore. So that's the point. So I think that the point of having industry-led research is that we have a very good set point. We know where we want to go. And as academics, we can develop the techniques to arrive at that point. So to me, being grounded by reality and by industry needs is paramount.
So I do have more questions, but I think at this point, I'd like to open it up to the floor and see if any of you guys have any questions for our amazing panelists, both in person and online, if there's any.
So speaking of humanoid robots, Seb Oakes has asked, are humanoid robots causing any waves in the sector? As the technology matures, it seems that it could be well suited to legacy facilities that are designed solely for human traversal.
That's true, but not yet. That's true maybe in 30 years. Yeah, but not now. Maybe. But I don't know. So there was a project with Airbus that was delivered in 2019. It was a consortium between DLR, the German Aerospace Agency, CNRS in France, and Airbus. And they deployed 2 robots that could work inside an airplane manufacturing plant. And I don't know if you know how it works. It's not like a car manufacturing plant. It's completely unstructured. You have this big hangar with a cockpit inside of it. Everything is very messy. So even for humans, it's very non-ergonomical. You need to go underneath, wires, pipes, and everything. It's very difficult to operate inside of it. And they deployed 2 robots with full autonomy, where the robot could, given a desired task, such as using a power drill to drill a hole in the cockpit, the robot would crawl underneath pipework, identifying everything, self-localizing, and then it would use different types of supports in order to increase balance, because when you use a power drill, there are reaction forces, you have torques, and for a robot, especially a humanoid, it's very difficult. And you cannot use just a bunch of aerial vehicles in combination with ground robots. It simply won't work. And they demonstrated. These are a published result. But again, it created some confidence on the potential of the technology. But of course, if now you change the type of task and you say, I don't want this robot to use a power drill, I want to use, you define the task very abstractly and ask the robot to do, it won't, right? Because this was a very restricted task definition, albeit the robot did everything autonomously. So I think that in order to have humanoids working as business as usual in a useful way, I think it's a long road ahead. Maybe 30 years, I would say, at least.
Okay, thank you. There's a couple more online questions. Another one is, for human-shaped robots, is there research into linking VR so the operator controlling the robot can experience the environment as if they were there?
Yeah.
Yes. We've got projects ongoing, not necessarily for humanoid robots, but certainly using VR as that kind of control. So yeah, those research projects are ongoing and something we're looking to implement in the future.
And VR and sort of haptic feedback as well, so you can feel what's going on in the world.
Yeah.
Thank you. Another one online is, are there test platforms or environments available for testing robot control algorithms?
So,
yes,
yeah.
in RACO, yes. We have a facility in Whitehaven, Cumbria. and we have equipment for hire as well. So if people want to go there and use the equipment, they can. We have a water tank with underwater vehicles, we have quadrupeds, we have humanoids, we have mobile manipulators, either tracked or wheeled manipulators, fixed base manipulators. So everything is there for use and hire. Yeah.
So if you don't want to go as far as Whitehaven, the university has lots of labs with
Yeah.
robots spread across
Sure.
lots of departments. Not as big as Reco, but still.
Perfect. And the last one I've got online for now is, to what extent do you think the overhyping/overestimation of the general public's perception of AI complicates the research and deployment of its use in nuclear?
How long have we got for this session? It's difficult. And it's come on, from my perception, very, very quickly. We've gone from really not seeing much AI to suddenly it seems to be everywhere. It's built into our phones. A lot of us are using it without really understanding that we're using it. And I think that's where we're going to see that difficulty, is that people are going to see it built into their phones and go, oh, well, I can do it on my phone. Why can't I do it at work? And it's that kind of cultural security barrier that I think is going to really impact us. We are starting to use AI. If you Google Sellafield AI, you'll see this strategy that we published a couple of years back on how we want to start using AI and how we plan to go about implementing it in a way that our regulators are happy, our operators are happy, and that we do it in the safest and securest manner.
Yeah.
You look at me.
Yeah. You look like you're going to say something.
I don't know what to say this, but just as fast as it's appeared and suddenly the answer to everything, it can disappear quite quickly as well. But we're on this artificial height curve where we're stuck at the top, but we can go quickly down the far side. And there's many people think that we're sort of beginning to hit the barriers with things like large language models and generative AI, where there's nothing else you can do after that. You can't upscale everything. We've taken all of the internet and trained this thing with it. What do you do after that? And so if we hit that barrier, then if people get too invested in this wonderful technology that will solve the world's problems, and suddenly it collapses, then it'll be another AI winter or something like that. Where we all don't trust it, and we have to be careful to say this technology is useful for some things, but there are other things where we're not going to use it for. We know how to pick and mix, pick and choose the right AI.
Thank you for the really interesting insight. I had a question about, are there like robots to save the robots? So if there's a robot that goes into an environment, something happens to it, it breaks, what is the procedure? Then people need to go back in. And also then if it has failed beyond repair, is there like a waste program for the components of the robots themselves?
So the answer is it depends. We are not yet at the stage, I believe, where we've used a robot to retrieve a robot, but we are looking on how we can do that. If the robot is retrievable without causing the human too much harm, we will go in and retrieve it. We do also have sacrificial robots that once they go in, they don't come back out until we decommission that. But the ones that we do retrieve, if they're no longer of use, we are looking at those waste routes. One of our challenges at the moment is anything where there's a battery involved, so particularly lithium-ion batteries. They are one of the barriers that we've got in. We'd love to use them because then it means we can do things remotely and wirelessly, but how do we safely dispose of that battery? How do we ensure that that battery is not going to overheat and cause us more issues if something was to happen to it while it was in a facility?
I think as well it's not necessarily about robots recovering robots. The primary thing is, can the robot recover itself? So best practice, again, for other industries as well, but especially for nuclear. Worst case scenario, if we're in a decommissioning job, for instance, we put the robot in, the robot breaks down, it actually just increases the decommissioning load because it's another thing in there that becomes contaminated. So for every drive axis, for example, the best practice is each, say you've got a wheel that's turning to drive the robot, that should have a backup motor and gearbox on it. So if the primary one fails, you switch over to the secondary one. So you'd have that connected by, we've done it before, by an electromagnetic clutch. So if the first one fails for any issue, if there's an electrical or mechanical fault, you can disconnect that, connect the other one, and get it to drive itself out. So that's core number one. Core number two is, and this is really going back to basics, but There's the battery problem. A lot of robots we've got are still attached by a big rope, essentially, as an umbilical cable. So that solves that problem. We deliver power to it externally. And also, from a really basic sense, you can pull it out. If it really goes wrong, you can just pull it out using this rope, which is really basic, but it's a really good fail-safe.
Yes. Yeah.
The other way of looking at that is it holds back what we can do, how far we can go, where we can get in. So that's a point for future research. We're still using that now. At some point, if there's a good way around it, it would be good to cut that tether and go in without it.
And we see that particularly as we try and make these robots smaller and smaller and smaller. You've got a big robot, so for example, our legacy ponds, they're about the size of Olympic swimming pools. So our umbilicals on our underwater ROVs are 50 to 100 metres. Now that's absolutely fine because it can swim freely through the water and things like that. When we're looking at putting a robot that's only 19 millimetres in diameter through pipelines, that tether suddenly gets very small, but the strain on that tether becomes immense the further it goes through that pipeline. So yeah, we'd really like to be stepping away from tethers, but then that's if it breaks down, how do we get it back out?
Depends on the situation. And then step number 3 is, I'm not seeing it so much in nuclear yet, but in other industries, we are starting to do recovery robots. So we've got another project running in our company where we're essentially doing internal tunnel inspection. And if the robot breaks down halfway along, that then causes a massive blockage, which is a problem. So we're looking at developing a system where you'd have a secondary robot goes in and is able to pull that first robot out if it breaks. So there's multiple angles of attack there as to how you solve the problem. But the primary one is make sure the robot doesn't break down and do everything you can to make sure that's what doesn't happen.
Yeah. And there are some techniques that you can implement in order to have a fail-safe strategy. So for example, there are techniques called fault-tolerant control, where despite having some faults, the system can identify it and cope with those problems on the fly. And this is not a mechanical strategy. It's not something that, it's not a spare motor or something like that. It's something that is embedded in how you design the problem, how you write the problem, and how you design the control system in order to make it happen. So a very simple example, imagine that you have a robot manipulator with 7 joints, let's say. And for some reason, it's operating inside a nuclear power plant, and the circuit board of 3 motors is just damaged due to radiation or due to debris, whatever. Now you have only 4 motors, right? So most techniques today wouldn't work for that particular robot. The robot would be dead, and there's nothing you can do about it. But if you have a fail-safe strategy where your controller just understands in a way that the robot lost 3 joints, so it needs to identify it, and it can operate with only 4 joints. So the number of things that it can do is restricted, but it might be sufficient for the robot to recover itself and come back, right? This is just one thing that we can think of. Another thing, and this is more science fiction, and it's related to autonomy. So if we're talking about an autonomous system that is able to recognize that other robot is with a problem, for example, and needs help, so you need first to have this degree of communication between robots, right? And you need a robot that now needs to deal with itself, but also with another robot autonomously, because there is no human operator to help in this task. If you want to do it in a general way, so you need very high level cognitive capabilities, right? And I think that we're not there yet. I think it'll happen when humanoids can be operated inside the power plant.
Thank you.
Thank you so much for such an insightful and interesting discussion. I have 2 questions as an AI and cybersecurity researcher. The first question, considering this majority of robots not designed and manufactured in the UK, and we are now that such a critical and high risk environment, what type of proactive cybersecurity measurement you have in plan in terms of the supply chain attack?
Would you like to start?
I would love to defer that to our commercial and cybersecurity team, if I'm being quite honest. The answer is it's quite stringent. We will not take onto site robots that are manufactured from certain companies, or if they can contain components manufactured from certain companies. The Boston Dynamics dog is a really nice example. So that has gone through stringent cybersecurity checking, and we particularly like that dog because it is very locked down. We can't access Spot's computer systems. Even if Spot physically breaks, we are not allowed to maintain him. We have to send him back to Boston to be fixed, and then he gets sent back to us. Now, that's all well and good. We'd love to be able to get to a stage where we can maintain him on site, and potentially we will get there. We're working much more closely with Boston Dynamics now, and our partners at Rayco were there this week as well. So hoping through that partnership we can expand on those. But the answer is it's stringent, and it's too much for me to understand and explain. But if you are interested, I could put you in contact with our cybersecurity teams who might be able to talk to you in a bit more detail.
I have a second question, sorry. AI, nuclear operation, robotics, and cybersecurity, so many high technical demanding skill. And knowing that with the DeepSeek happening, revolutions, and Microsoft quantum computing chips, are we ready to fill the gap regarding with the people who need in this special high critical?
So my take on this is a little bit different in terms of how I approach the cybersecurity thing, because I don't use the Spot robot in my work. Essentially because I need to have low-level access to everything in order to program those robots. But everything is open source, so you can audit it, right? So if you want to certify it, if you want to do something, you can actually see the code. And those robots, they are not connected to the wide internet. When they operate, if you need some degree of communication, you can have secure communication, but locally, right? So there is no one tapping into the system. And coming back to your second question, which is the AI thing, I think that we need to have several layers providing guarantees at the lowest levels up to the high level. Even if you want to use something that is very high level, that might use artificial intelligence, this is not what I do, right? But if you wanted to do that, you need to have low-level safeguards. So for example, a very specific one, but just to illustrate. Suppose that you have a robot operating inside a glove box, and which is, I don't know if you know, a glove box is those cubicles where people insert their hands through portholes, and they're protected by gloves so that they can manipulate dangerous things, such as nuclear material or biological tissues, things like that. So those are glove boxes. In the nuclear sector, we deal with nuclear material. So suppose that you are using an AI in order to perceive the environment and feed that information back to the robot. If you have low-level controllers that ensure that the robot will not, for example, bump into the wall in order to break it and release that contamination, right? The AI can do whatever it wants. It won't do anything because you have that degree of certainty that you can mathematically prove. This is what we do, right? So I believe that if you have something that you cannot introspect into in order to understand what's happening, you need to have these safeguards, always. No problem.
Well, thank you very much for your talk. It's been really interesting kind of listening to you guys talk about it. Robotics as a whole offer a really kind of interesting opportunity to do fully closed and isolated systems. And for very extreme environments like space, as you mentioned, and nuclear especially, that is very, very kind of appeasing, because you don't then need to have a external personnel or external robot kind of inserted into that system to fix it, to kind of observe what's going on, if you already have a system in place for that. So how can robotics kind of address that and potentially be implemented into those kind of future systems?
So I think this is where, when we were talking about nuclear fission, we're building these new power plants and we are aware enough of robotics at the design stage that can be built in. Fission's really interesting because that is such an extreme environment that you cannot send a human in to do any of the maintenance. So it will have to be robotics.
People still try to.
Yeah.
the industry still thinks to a certain extent it's easy to send a person in, and that's kind of a war that we wage, especially as a robotics team, trying to turn that thinking around.
People like UKAEA are looking at that, and they're developing these ginormous robotic solutions. And I think we've missed it for nuclear fusion. Even the plants we're building now, that design process has started so long ago that we still haven't got robots in there as business as usual, even in the plants that are being built today. So I really think that fission is where we can kind of see that difference in, we've thought about this plant, we've thought about how we're going to use robotics in it, and we've thought about how we're going to use robots to decommission it.
Yeah, to be honest, it's STEP we're looking at as kind of the next iteration along from ITER, which is currently being built. And the problem is that everybody's aware of the problems of fission and the old plants, that they weren't designed with any real future maintenance decades down the line in mind. So we are thinking about that now, but there's a challenge in itself that the design of ITER, the next generation fusion plant, is, I'm not sure if it is the biggest, it's got to be one of the biggest science and technology projects in the world.
Yeah.
And there's so many different people feeding into that trying to get robotics on the top of the agenda for all the design constraints for such a complex design is really challenging. It's about setting that agenda that it is thought about at the top. And what we're pointing out with ITER now is we've just done a project where we're looking at there's vacuum seal port plugs, which is just one tiny element of a massive system. But they've got to have a vacuum seal on it that attaches and detaches for maintenance purposes, and obviously has to be attached when the plant's in operation. As it stands on ITER, it's not the core, but it's a surrounding area that you still don't really want people in. It's probably going to be done as a manual operation because there hasn't been, it's as simple as there just isn't the space envelope to, without spending billions of pounds to make something so infinitesimally tiny, we can't physically get a robot in the space. There just isn't enough room. So what we're hoping is it's now been recognised during the development of ITER that we should be doing that. We want to do it. We're doing studies into it, where we're now looking ahead to already the next one along from ITER, which is STEP. As we go through these, we're hoping this next one, we've got enough people saying it and there's enough momentum behind it that now robotics is going to be one of the top priorities when we design a plant, and make sure that is given the number of requirements it needs, and they're taken to the high enough priority to make sure we have got that thought about from the offset. So it needs to be done from day one.
Thank you very much.
Can I take your question and answer the question I want to answer? Related to that, which is, we talked about going from humans remotely controlling a robot to autonomous robots doing things. The next step after that is autonomous robots working with people in a team to do things together. And as you mentioned, sometimes you will have humans there doing things, but maybe they're not directly controlling the robot. They're working as a team together. And we have, for example, in Cradle, we have people working on how do you mix together humans and robots in teams to work together in a, again, trustworthy way to trust the robots and various things. So I think that's a step further on, but it's a sort of end goal. And not just the nuclear, it's almost like domestic robots as well. How can you get humans and robots to interact together in a sensible way, reliable way, trustworthy way? But it's far along.
To put it into a little bit of context, Sellafield wasn't even built with how we would decommission it in mind, let alone decommission it using robots. So it's that step change that we're looking at. It's a cultural thing. It's not a technology thing, it's a cultural change.
So, and that's how we're kind of moving through the decades, really. Sellafield, it wasn't even thought about.
Yeah.
It's being thought about. It is on everybody's agenda, but it wasn't thought about early enough. We're hoping that when we get to STEP or demo, which are looking at the future fusion reactors, hopefully we do get in there early enough and we can look towards more of a full implementation of robotics.
Yes, so I wanted to come back to a statement that has been done that open source allows you to be secure. That is not true. Basically, You have systems that are completely open source like Linux that have plenty of vulnerabilities. You have compilers, and that doesn't ensure you that you have cybersecurity. So please be careful with that kind of statements of open source equaling security. The other part is when you put actual processors and chips, those are not open source. They are closed source, and they have different supply chains in which you can be intercepting and have attacks happening. So the statement that you have open source systems being deployed into nuclear system is not correct either. So trying to move on to AI, I've seen a lot of discussion of whether it's going to be successful or not going to be successful, but I have not heard much about collecting data. For AI to actually be successful or not, you need to collect data. So I was part of the Dalton of the RAIN project, looking at computer vision in that. And one of the frustrations that we had is there was a lack of data sets and challenges that we could actually use as an open community, as a challenge that we can actually make progress with it. So is there any plans of actually collecting for enabling digital twins and being able to make progress without actually having to go and deploy, so that we're able to build trust in steps? You don't have to make everything available. You can actually set up different challenges.
Can I address the first question?
Of course you can, Bruno. Yeah.
So let me clarify. So my statement wasn't about equivalence, right? I didn't say that being open source is equivalent to being safe. So actually, it's a stepping stone for auditability. You can audit it. But of course, this sector is highly regulated in the same way that the medical sector is highly regulated. The aeronautics is very regulated as well. So you need to pass through the regulator as well. So being possible to audit is just a way of saying, look, I know what's inside. Those components, they are black boxes. So how can we certify those? So this is not my job, right? I'm part of the equation because I'm developing those systems. But as Mel said, so we have a cybersecurity team in different institutions, University of Manchester, across the NDA sector, and they work with us in order to make it happen. So it wasn't an equivalent, a statement about equivalence. It was a statement about auditability, at least in the part we operate on.
That's correct. But a lot of people only consider the software for cybersecurity.
Oh, yeah.
And the hardware is as important.
Yes.
Especially when you're looking at supply chain attacks. And that has been demonstrated in several, the recent years of attacks actually have happened at the hardware level. And there is also expertise in the university.
Oh yeah, no. So just to follow up, that's why it's a pain deploying those robots. So if you see our work that we do, so the percentage of deployments is about, I don't know, 5%, 10%, because exactly of what you said. So we need to pass through all the hurdles, the security hurdles, in order to make it happen. And I think it's correct. I think that we cannot just deploy as we want, because there are safety considerations that need to be taken into account. So that's why we have RAICO, because we can de-risk the technology in terms of the concept, but then after you believe that the technology is right, so then you can use certified equipment to then deploy on site. So RAICO was created, it's a follow-up of RAIN, right? To de-risk this type of development, because we can do in a facility that is not nuclear, but we have input from the nuclear industry.
To bring it into something a bit more everyday, my work laptop, I'm not allowed to use wireless headphones with it. If I want to use a headset, I have to order one through our company, and that is the only one I'm allowed to use. I'm not allowed to plug my own headphones into it. I'm not allowed to use wireless headphones. And that is just something on the very basic level that we all do all of the time, is we use a headset to have a work meeting. So that's a very basic thing, but we're already at that kind of level of security for our systems. Onto your second point, I'm going to slightly disagree. We have lots of data. We have too much data. The problem is it's either the wrong data or it's not in a usable format. So yes, we are looking at how do we collect better data? How do we only collect the data we need, not everything that surrounds it? And then how do we declassify that information so that we can make it accessible to academia and supply chain?
I'm going to have to end it there because we have just ran over a little bit, but I don't know. You guys will have to shoot off, but if there's a couple of minutes afterwards and you want to ask questions, I'm sure that'll be fine. But can everyone join me in thanking our speakers for an amazing panel discussion?